Hey, what's up guys? So I think everybody's familiar with your standard run-of-the-mill Arduino board where it's got the familiar Atmel ATMEGA328P-PU processor with the external 16 megahertz crystal running at a system voltage of 5 volts. Okay, that's pretty standard. But what I'm going to do in this video is actually modify a few of those parameters and actually violate the specifications in the data sheet for this part. So what I've got over here is a board that I'll actually talk about in a future video here, but just to give you the gist of it, it's a what I'm calling the platform board, and it's got these little slots for customizable little boards that plug in. And what's here is basically just a 5 volt input, a 3.3 volt linear regulator powering up the board, a BLE module board here that we're going to communicate with a smartphone app there, and then that is communicating to this center board here, which is an Arduino clone. It's a surface mount version of the ATMEGA328 there, running at 16 megahertz with a system voltage of 3.3 volts. So that's in violation of what's shown in the datasheet, and they've got a little chart there that shows that you need to lower the frequency if you're going to lower that system voltage. So, and that's why a lot of times you'll see the 3.3 volt versions of the Arduino with a frequency crystal of 8 megahertz. So anyway, what we're going to do is in violation, and we're going to run some tests here. And what I thought would be a good test is to run these WS2812B Addressable Rgb LEDs, because the timing required to drive these LEDs needs to be so precise. So if there's any drift in that timing at all due to, you know, the processor not being able to run at that frequency with that voltage, we'll be able to see it. So we're going to really beat on that processor too. I've got the heat gun out. We'll also put the board in the freezer, and we'll see if anything visibly changes on these LEDs. So let me show you really quick how this will all work. Now, by the way, I know we're also testing the BLE board, the linear regulator. So there's some other variables in the system, but if anything should go wrong, then we'll start to isolate the processor just to test that by itself. But hey, if the whole thing passes, then I'm good, because it also tests the BLE board in extreme temperatures. So we've got the app here, and it looks a little busy, and I'll talk about this again in a future video, but we've got this 3 sliders at the top there for background LEDs, and basically what that means is it's lighting up the entire strip with some color, and we got 3 sliders for RGB there, so I'll leave it just at red there. And then we have these 3 sliders for the foreground LEDs, and then foreground position and length. So let me give that some length there, and then I'll give it a color of blue, and then you'll see on camera there as I move the position of that, I can kind of move those around. I can change the length of it. So I'll talk about this in a future video, but this is all part of a project for my desk lighting here, so that I can make that foreground LED all white, you know, move the position around. So now I have a work light, or I could split it and run animations. Anyway, it's a whole thing. But what's nice about this is that we'll be able to control those LEDs and see if anything should change. So let me get that set up here. I'm going to do half red and half blue, and if we see any flickering or anything suspicious at all, then we know we've got a timing problem. So let's go ahead and move that all the way up to the top here, and we'll go about half blue, half red. Okay, cool. So obviously it works great at room temperature. I've got a little probe, one of these little infrared temperature probes here. It's at like 23.3 C, and we're just going to take a measurement of the surface of the processor. And it's not a precise test at all, but it'll just be a first round kind of thing to see if we have a problem. So now let's start hitting that board with some heat. Okay, so we're all set up. I've got this bowl here with some capped on tape, and I've done these kinds of tests before using this bowl. So we've got the high temp tape in there. It's insulating the board from the bowl, and it's lifted off of the desk here so I don't burn anything up. So let's give it hell with the heat gun here, and I've got it set to high. And we're just gonna raise that temperature up. And in a future test, I might actually put this in a in an oven to better control the temperature and do some endurance testing. So we'll actually run it for, you know, a day at different temperatures to see how it does. And I'm going to occasionally change the temperature there just to make sure we've got Bluetooth, a good Bluetooth connection, and the Arduino's able to change those LEDs. Now keep in mind we also have a software UART running between the BLE board and the Arduino, so it's also testing that. And I believe the baud rate is 9600, so it's a pretty slow baud rate. But it's testing that and then also running these LEDs with that sensitive timing there. Okay, so I'm not seeing anything wrong with driving 300 LEDs. Let's take a quick measurement there. All right, so this is showing me a surface temperature of around 97. But we'll just keep hitting it with the heat gun so that we can bring that temperature up, you know, and let all the internals heat up as well. I'm gonna lower that a little bit there. Okay. I'll try changing the foreground LEDs. No problem. Go green there. Yeah, no, not a problem. Okay, it's very hot. It's hard to even touch that. Okay, no problem at all. Still running fine. And mind, you know, the other thing too is we're running a linear regulator here. Ooh, and that tab is really hot. And I even have some electrolytics in there too. So that was the idea here, is that if I started seeing failures, then I'd investigate and see if it really is the Arduino failing on us or something else in the system. Oof, it's really hot. Yep, no problem at all though. Still able to run those LEDs. Let's take a quick temperature reading. Remove the heat when I do this. Okay, 101. Just kind of looking around the board there. Yeah, everything is easily above 85°C everywhere I look. Okay. Which would be totally fine for me. Anything above 85°C is great. Or even if I could just hit 85. You know, if I started seeing failures at 85, that would be totally fine for this. Okay, oops, I had some sliders turned on there. I'm going to turn everything off. There we go. No problem. Okay, I'll just let this go for another couple minutes here, and we'll come back and see if everything still works. Okay, not a problem at all. So that's pretty good actually, and these components are very hot. Oh yeah, they're toasty. The bowl's very hot. So let me just take a quick reading there. Okay, so we're still above 90 degrees C in there. We'll give it another couple minutes here. You can see I'm pretty close to the boards now. I don't want to start melting anything though. And it looks like I am starting to melt the little wire connectors there. Okay. Yeah, it's still good. Check the blue out. Yeah. Okay, wow, it's peaking at around 113 there on that surface, and on the BLE part as well. Wow. Let's see what that tab is. Yeah, everything now is over 100 C. Alright, I think that's pretty good. At least good enough for me. You can actually see, before I ran this test before I started making this video here, but I was really beating on it, and I actually melted the power barrel jack connector there. So that just shows you that it's still pretty robust. So running it at 3.3 volts with 16 megahertz at high temperatures seems totally fine. So let's actually now throw the board in the freezer and see what happens. Okay, so I've got the board in the freezer, and it's all set, ready to go. We're connected to it. Got the LEDs on, and so we'll just button this up real quick, let it sit, and we'll revisit this in about 20 minutes or so. So the freezer temperature, I believe, is set for -18. We'll check that at the end just to make sure, but that's what the freezer setting is for right now. And one of the cool things too is that we're outside of the freezer with the smartphone here, and we're still able to keep that connection to the board, no problem at all, and control those LEDs. So you can see we're still able to control the red LEDs and the blue LEDs. We can move the position around there fine. So we're maintaining a pretty good connection with that BLE board, even though it's in the freezer. So that's pretty impressive. So anyhow, we will let this sit for about 20 minutes or so, and we'll be right back. Okay, so that's been about 20 minutes there in the freezer, and we maintained the BLE connection the entire time. I made sure that I kept the app open so I could keep an eye on that connection, and I was occasionally flashing the LEDs and moving them around and making sure that there's no flicker or disruption in any of the colors there. So yeah, this is pretty good. I mean, we're able to bring that temperature up above 85 C, and everything worked fine. And now we're at -18. I'll check that temperature in a second here, but I'm pretty impressed. So I mean, that's good enough for me to actually design this into a board for my own projects. So for further testing, we'd obviously want to bake these boards in some kind of oven with a controlled temperature, and for some period of time as well, just to make sure, because I'm just doing quick tests here. But anyhow, this is pretty good, and I'm happy with these results. So if there's anything else you guys think that maybe I should test at running this processor at 16 megahertz with a 3.3 volt voltage, let me know. So anyhow, that is the video. Oh, let me check that temperature real quick. Okay, the temperature is about -14, -15. So that's pretty close to -18. But anyway, that is still pretty good. And that is the video. Thanks for watching.